Hello, AP Calculus. If you're watching this, that means that I haven't scared you away yet, which is a good thing. Or maybe that means I need to try harder. Who knows? But anyways, uh, today's Thursday, even though I'm recording this on Wednesday. But today's the second day of AP Calculus, and we're gonna kind of jump into it, but it's also going to be a really quick review. I'm going to use about 4 days, or really 3 days now, to do a review of topics that you should have learned in Algebra 2, Geometry, and Pre-Cal. So then that way, when I get back next week, we'll do another day of review and then just hit the ground running with Unit 1. So just a few reminders as I start sharing my screen. Make sure that you are getting a notebook for this class. You'll at least want probably a 2-inch binder for the course packet that you're going to get on Tuesday, but then maybe like a 1-inch binder or a 1/2-inch binder even for carrying stuff back and forth each day. I don't expect you to carry all 500 and some odd pages every day. I don't expect that. But you do need to have what we're doing that day with you. So for Tuesday, at least, you'll want to bring the whole 2-inch binder. That way you can put your course packets in that binder. After that, that's the only day you really have to bring the big binder. Then you just need a little binder. But anyways, for those of y'all that have already gotten into Google Classroom, thank you for that. Just a quick check as of about 2 o'clock on Wednesday, I see that 8 of y'all are in Google Classroom. So hopefully we can keep that number going higher as time passes. Hopefully by the time you're watching this video that most of y'all have gotten into Google Classroom. Another thing is you'll want to make sure to get the unilateral contract signed by both you and your parents, and then turn that into the sub. So if you have that today, get it out and turn it into Miss Malinar. That way they'll be ready for me to just file away when I get back on Monday. I almost want to put out like a little challenge. See if y'all can get all of your forms signed and brought back before I come on Monday. See if you can do it. Can you? I'm going to say no, but maybe you'll surprise me. Anyways, yeah, just make sure you're in Google Classroom. Make sure you're getting that. You may also want to start studying the unit circle on the package you got yesterday. Start trying to memorize the whole unit circle, not just the first quadrant, but all 4 quadrants. Start memorizing those again. I know it's now 1 day removed from summer by the time you're watching this, but you'll need to know your unit circle frontwards, backwards, and upside down. So start learning that now. Or not learning, but start remembering that and memorizing it. Okay. With that said, let's kind of get into the lesson for today. For those that don't know me or haven't heard about me or anything, almost every topic I have some sort of meme for. So today you're going to see 2 memes. But I mean, hey, it keeps things interesting. If I can make you laugh by showing you a math-related picture or comic or something, more power to me. Laughter is medicine, as they say, even if it's in math. Okay, so today we're going to look at the inexcusable algebra mistakes of calculus. This is one thing that, even though this is only my second year, reading things from people that have been teaching it year after year after year after year, these things that we're going to talk about today are things that make the graders cringe every summer when they see calculus students making these mistakes. And in some cases, it makes them cringe so much, they start taking points off. So we're going to try to nip this in the bud now that we're not going to make these mistakes. And if we do, it could be bad. So the notes really are notes. There's not much to write down. I'm just going to kind of talk through this reference sheet. And then you'll have an assignment afterwards. So again, these are some common errors, along with 12 functions that you should know and understand without any aids, meaning without graphing it or anything like that. But we'll get to that on the back of the notes. So common errors. These are non-negotiable basic skills you should know. The first one, I have a meme for that. X plus 9 all squared does not equal x squared plus 81. If you say that, you're forgetting the middle term. You're being like the guy in the meme. I think I forgot something. If you forgot, then it wasn't important. Yeah, you're right. And they left out the 2x plus y, or 2xy. So in our case, it'd be like leaving out the 18x. There should really be... Oh, where's it at? Control. There we go. Right in here, there should really be a plus 18x. I'm actually going to do that in a different color. If you want to write these notes, you can. But on today's, you don't necessarily have to. There we go. Got it. You don't necessarily have to write them today because they're kind of all filled in. But we need that plus 18x there. And as far as the algebraic property goes, they have a general form right here. A squared plus or minus 2ab, depending on what this sign is, that tells you what that sign is going to be. And then the last sign is always positive. So this is the same. This is always positive. Okay, the next one. If we take the square root of x squared plus 81, we cannot say that that's going to be x plus 3. I don't even know how they got 3. The square root of 81 is 9. But still, we can't say it's x plus 3 because this is not equal to the square root of x plus 9 squared. It's not equal to that. So it can't even be x plus 3. No, don't do this. If you're square rooting something that's squared, then it's going to be the absolute value of x plus a. So if x plus a is negative, then it's going to have to be the positive to square root it. Because remember, we can't take the square root of a negative number. That gives us imaginary numbers, and we're not going to deal with imaginary numbers in calculus. Okay, next one. X plus 5 over x equals 1 plus 5 over x. That's okay. We can say that. But we cannot say, if I take the reciprocal and say x over x plus 5, that is not equal to 1 plus 1/5 x. We can't split that up. We cannot do x over x plus x over 5. That's bad. We can't do that. So that's why these are not equal. You can't You can't split up the denominator like that. You have to keep the denominator whole. So if you have something on top, a plus or minus b over c, if you have a single term down here, then yes, you can split up that single term and say a over c plus or minus b over c. But if you have two terms like x plus 5, we can't split it up. We've got to keep them together. And then that's a similar story for the next mistake. 2 plus x over 5 all over 3 does equal 2 plus x over 15. They take this 5, it comes down here, and it's multiplied by the 3. What you cannot do is multiply this 3 up there to the numerator. That's not allowed. You can't do that. That 3 has to stay in the denominator. Now, if this was 1/3, then yes. But just 3 by itself, no. 3 stays in the denominator. That's what they say here. A over B all over C is equal to A over B times C. And then we have a little bit with exponents. 4x to the negative 3 is equal to 4 over x cubed. And then if you have 4x all raised to the negative third power, that'd be 1 over 64 x to the third power. Because what they had to do is they had to say 1 over 4 cubed and x cubed. That's what this piece really is. And then they put that into symbols. So that's all they did for the next column. B to the negative n is equal to 1 over b to the n. If you have 1 over b to the negative n, that's equal to b to the n. So okay, some algebraic foundations. One thing we're going to use a lot in this class is called point slope form of a line. I guess I should write that over here. Point slope form. We're going to use this form for a line way more often than what we'll even use slope-intercept form. So y equals mx plus b, yes, we'll use that. But more than anything, we'll be using point-slope form. Which is y2 minus y1 equals slope times x2 minus x1. Sometimes the y2 and x2, those are just y and x. Like in our example here, if the slope is negative 3, our point is 2, 7. Well, of course, there's our m. There's our x1, our y1. So y minus 7 equals negative 3 times x minus 2. We're going to use that, like I said, quite a bit. Well, on factoring, a little bit of, when it comes to factoring. A squared minus b squared, you've heard this one called the difference of squares. We can factor that to be a plus b times a minus b. But a squared plus b squared, that one is relatively prime. That's a sum of squares, and for the most part, you can't factor a sum of squares. Now, when you have cubes, like a sum of cubes or a difference of cubes. So this is a sum of cubes. The second one's a difference of cubes. for that one. So a cubed plus b cubed yields this piece as factored. A cubed minus b cubed yields what you see there as factored. The way to remember your signs and what sign goes where, think of the word so. Same, opposite, always positive. So when you go to factor a cubic, the sum of cubes or a difference of cubes, the first factor, the binomial piece, that's going to have the same sign as whatever you're factoring. So if it's a cubed plus b cubed, then that binomial is going to have a plus. A cubed minus b cubed, the binomial is going to have a minus, the same sign, the opposite sign, and then the last one is always positive. Same. I'll write that here. Same, opposite, always positive. There we go. Same, opposite, always positive. That's how you can remember what sign goes where. And then as far as trig identities, I know you learned a lot of them in advanced pre-cal. We're not going to need a ton of them here. You'll need the basic ones, but then you'll want to know the basic trig values for 0 to 2 pi, which is your unit circle. That's what I've been saying. Know your unit circle. Know your unit circle. Know your unit circle. You won't have time on the AP test to sit there and draw your unit circle out every time. You'll just need to know it. But some of the identities you'll want to remember are sine squared plus cosine squared equals 1. 1 plus cotangent squared is equal to cosecant squared. Tangent squared plus 1 is equal to secant squared. You'll want to have those pretty much memorized. And then you'll also want to be able to communicate solutions through written mathematical expressions. So basically, be able to interpret your answer. Don't just say, oh, my answer is 5. Okay, that's the numeric value of your answer, but 5 what? Kilograms per second? 5 meters? 5 feet? 5 apples? What's 5? Later on in Unit 1, we'll learn an acronym called NUT. N-U-T. And that'll help us be able to format our answer. And if you're going to laugh at this, but it won't be uncommon for me to ask you, did you remember to nut your answer? But anyways, okay, so let's look at the back. The 12 basic functions you'll need to know without any reference. Without a calculator, you just need to know these. Y equals x, of course, that's just a linear function. Y equals x squared is your parabola. X cubed, that's the one that, I don't know how to explain it. That's this one. I know what it looks like, just explaining it. It's kind of hard. Absolute value of x, that's the v. Let's see, what else? The square root of x. Remember, it's not defined when the value under the radical is less than 0. So that's why it looks like in this graph, this parent function, it starts at 0 and then just goes to positive infinity. It can't go to negative infinity. 1 over x, In Algebra 2, these were your rational functions. The sine of x, the way I remember sine and cosine for the parent function, sine goes through the origin. Sine goes through 0, 0. Cosine goes through 0, 1. Because the cosine of 0 is 1. And then e to the x, that's an exponential. So it crosses at 0, 1 and then starts growing towards infinity. The natural log of x, it's going to start at going down the negative y-axis to negative infinity, then cross, have an x-intercept at 1, and then start climbing to positive infinity, but slowly. 1 over x squared, and then this one is a semicircle. The square root of a squared minus x squared. This is your semicircle. This will be big, really big, coming up in Unit 8. I'll say coming up. Unit 8's not going to be till next semester. But we'll really start hitting semicircles pretty hard. So you'll want to know that function as well. Okay, so these are, when I was looking at this sheet, I'm like, why does this remind me of a meme? And then I happened to see this one online. So here's your functions. We need to know this dance move, the x squared, x cubed, sine, cosine. You do need to know tangent. It's not on this page, but tangent's a good one to know. Maybe not cotangent. You could say 1 over x, negative 1 over x, absolute value, negative absolute value, negative line. A to the x, that's like your exponential, your circle, or your semicircle. So think of these functions as dance moves. Maybe we should create a calculus dance this year. Who knows? But anyways, so that's kind of the lesson for today. Just trying to jog your memory on things that you probably forgot over the summer. But that's the lesson, your assignment for today. Let me pull it up. If you're wondering what all these are calculus memes. I keep a whole folder of calculus memes. I'm that nerdy. Yes, I know. Okay. So for your homework, it kind of goes with today's notes. The first 4 problems, I want you to correct the error. So how could you take the original one they give you and make it correct? Because we're going to say a student tried to do this, what they did is wrong. So what would be the correct answer? That's the first 4 problems. And then for the rest, just follow directions. Like you're factoring for the next, looks like 8 problems. And then you're writing each fraction as a sum of 2 or more terms. You're simplifying exponents. And so that's your assignment. You'll have the rest of the period to work on it. Hopefully you finish it. If you do, get it turned in. If you don't, then it's homework and it's due tomorrow. But anyways, that's kind of it. It's short and sweet today. That way you have plenty of time to work on the assignment. And hopefully you won't have any homework tonight. But if you have any questions, you can email me. My email address is in Google Classroom. I'll show you all again where it's at. It doesn't look like they've gotten our mind set up yet, which is kind of aggravating, I'm not going to lie. But to get my email address, you can go to class resources, contact info. There's my email address if y'all have questions that you want answered now. feel free to email me. Even though I'm still recovering, I check my email pretty frequently. Anyways, that's it for today. Just remember that you are loved, you're created to do wonderful things, and you are awesome. Always believe.